Have you ever gazed up at the night sky and wondered about the universe's most mysterious objects? What if you could get up close and personal with one of them, a black hole? It sounds like a scene from a science fiction movie, right? But what would actually happen if you fell into one? Today, we're embarking on an incredible and admittedly terrifying journey to find out. So buckle up, because we're about to dive into the heart of darkness. First, let's get our bearings. What exactly is a black hole? Imagine a star, much more massive than our sun, reaching the end of its life. It collapses under its own gravity, squeezing an immense amount of matter into an infinitesimally small point. This creates a region of space-time where gravity is so strong that nothing, not even light, can escape. The boundary of this region is called the event horizon. Think of it as the point of no return. Once you cross it, there's no coming back. Now, let's say your spaceship has had a bit of a mishap, and you're drifting towards a black hole. Your experience will depend heavily on the type of black hole you encounter. Let's start with a smaller one, a stellar mass black hole, maybe just a few times the mass of our sun. As you get closer, you'd start to feel something very strange. The gravitational pull on the parts of your body closer to the black hole would be significantly stronger than the pull on the parts farther away. If you're falling in feet first, your feet would be pulled much more forcefully than your head. This difference in gravitational force is what scientists call a tidal force, and it's not a gentle tug. It would stretch your body, elongating it like a piece of spaghetti. This rather gruesome process has a fittingly dramatic name: spaghettification. Every single part of you, from your bones to your atoms, would be stretched and pulled apart until you reach just a thin stream of particles spiraling into the abyss. It's a quick and certainly not painless end to your cosmic journey. Before you even reach the event horizon, you'd be completely disintegrated. So, let's just say, steer clear of the small ones. But what about a much bigger black hole? A supermassive black hole, like Sagittarius A*, at the center of our own Milky Way galaxy, which is millions, or even billions, of times the mass of our sun. These galactic giants are a different story altogether. Because they are so massive, their gravitational field is more uniform over a larger area. The tidal forces near the event horizon are much weaker. This means, hypothetically, you could cross the event horizon of a supermassive black hole completely intact. No spaghettification, at least not yet. You might not even notice the exact moment you've crossed the point of no return. It could feel just like floating in space. So, you've survived the crossing. You are now inside a black hole. What do you see? This is where things get truly mind-bending. From your perspective, looking out, the universe you left behind would appear distorted. The light from distant stars and galaxies would be bent and warped, all concentrated into a tiny, bright spot in the sky behind you. It would look like you re-looking at the entire history of the universe playing out in fast forward in a small window. Time for you, relative to an outside observer, would be slowing down dramatically. If someone back on Earth could watch you, they would see you appear to slow down as you approach the event horizon. getting redder and dimmer, until you seem to freeze and fade away forever. They would never actually see you cross. But for you, inside, time marches on. You're now on a one-way trip to the center. There is no turning back, no fighting the current. Inside the event horizon, space-time is so warped that all possible paths lead in only one direction, towards the center, towards the singularity. The singularity is the heart of the black hole, a point of infinite density, where all the mass is concentrated. Our current laws of physics, Einstein's theory of general relativity, break down here. We simply don't know what it is or what happens there. It's one of the greatest unsolved mysteries in all of science. As you continue your fall towards this ultimate unknown, the tidal forces that were so gentle at the event horizon of the supermassive black hole would start to increase exponentially. The stretching force would become immense. So, spaghettification is not off the table. It's just been delayed. Eventually, you and your spaceship would be torn apart, atom by atom, just like with a smaller black hole. The stream of particles that was once you would continue its journey to the singularity, its fate sealed. So, is that the end? Just a stream of particles crushed into an infinitely dense point? Maybe not. Some theories propose other, even stranger possibilities. One idea is that a black hole could be a wormhole, a bridge through space-time to another part of our universe, or even to another universe entirely. According to this theory, instead of being crushed at the singularity, you might be shot out of a white hole somewhere else. A white hole is the theoretical opposite of a black hole, a region of space-time from which matter and light can escape, but nothing can enter. However, there's no evidence that white holes exist, and most physicists believe this scenario is highly unlikely. The intense forces inside would still likely destroy you long before you reached the other side. Another mind-bending idea comes from the holographic principle. This theory suggests that all the information about what falls into a black hole isn't lost forever at the singularity. Instead, it gets encoded onto the two-dimensional surface of the event horizon, like a cosmic hologram. So, in a way, a version of you all, the information that made you, you would be imprinted on the boundary of the black hole for eternity. This idea tries to solve a major conflict in physics known as the black hole information paradox, which pits Einstein's theory of relativity against the principles of quantum mechanics. So, what have we learned from our perilous journey? Falling into a small black hole means a quick, spaghetti-like end. Falling into a supermassive one gives you a brief, surreal experience of crossing the point of no return. Seeing the universe flash before your eyes before you too are inevitably stretched into oblivion on your way to the mysterious singularity. While the idea of wormholes and holographic information is fascinating, the most likely outcome is complete and utter annihilation. Black holes are not just cosmic vacuum cleaners. They are the laboratories of the universe, pushing our understanding of space, time, and gravity to their absolute limits. They force us to confront the biggest questions in physics and cosmology. While we may never be able to send a person to one, by studying them from a safe distance. We continue to unravel the secrets of the cosmos. So the next time you look up at the stars, remember the incredible, powerful, and mysterious objects lurking out there, shaping the very fabric of our universe. Thank you so much for joining me on this wild ride into a black hole. What other cosmic mysteries would you like to explore? Let me know in the comments below. And if you enjoyed this journey, don't forget to like, subscribe, and hit that notification bell so you don't miss our next adventure. See you next time.